Hello everyone, this is Dukla Dutta. Welcome to my YouTube channel. Today we'll discuss in this video regarding this problem, merge two sorted lists. Now we have this problem number 21 from problem LeetCode problem set. Now this says you are given the heads of two sorted linked lists, list 1 and list 2. Merge the two sorted one list into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list, right? So basically you have been given, so let's say understand using the diagram given here. So the example is given like this. So what we have to do is we have, let's say the list 1 is 1, then we have 1, 2, 4, right? So this is a list, let's say this is list 1. And then we have list 1, 3, 4. This is list 2. Now what we have to do is, let's say the output result, or you can name it output. So in this case, we have to do it like this. So this is 1. You can take any of the ones because both are equal. Then you take the next lowest number. So this is 2. Okay, instead of that, we have to get the 1 also, right? There's 2 ones. We have to get this one. Next, we have 2. Then we have 3. Then we have 4 and 4. So this is what we have finally. This is the output we have to send. Like it will automatically generate the output and this following the array. What can be done in a brute force manner is that you can simply use an extra and come like traverse each of the list and come like make it into an array. Then add the both the append one array to the other. All right, and then you can just sort it and return the list by making a linked list. That is there. But what we can do is we can simply, while we are like building out, while we are traversing each of the list, we can simply just compare the current node values in each of the lists and see whichever is lower, we just append it to the result. And then we just move our pointers like to the next nodes in each of the lists. Okay. So what we can do is, you can just do a dry run here. Like see, let's say we have the current node over here, current node over here. Now we compare both of them. So it's equal, right? So we can just append any of one of them. So we append here. All right. So this is one. Now next we can move any of them. Like it's up to you which one you want to move in case of same node value. So let's move it there. Now we compare these two nodes, the values of these two nodes. We see that one is there, one is the lowest one. So we move this pointer over here and add this one to from here. Like we take it and add it here. All right. So what we do is then next is we just like move the pointer of the list 2 to this position. All right. Now next one, what we do is we compare. Now one is added. Now we compare the current nodes. All right. So list 1 and list 2. Right. So what we can do is we compare these two nodes. So 2 is less than 3. So we add here. Okay. And then once we have added this 2, we move the next pointer to to the next node on the list 1. Similarly, we can like continue doing it, okay, unless one of them ends or both of them ends together. In this case, both like in any case, like it depends what the input is. So it could happen that either of the list finishes off first. Okay. So in that case, you have to just again go through the go over the list which has not finished yet. Okay, and then add the rest of the nodes from that list to the result. All right. So let's go through the code. So code is very straightforward. All right, if you already know linked list, if you do not know linked list, you have been given the structure over here, list node class. All right, so what we can do is now we have to have a new like node which we can use to keep track. of the head of the result with the array. Now we have to keep moving the pointer in the result also, right? As we add the new nodes. So we'll keep like take these two, one dummy node. Okay, you can name it anything. Just make sure what it like what you're referring to. So what we have is, let's say list node uh, is not zero, list one is not null. Okay, and list two is not null. All right. Now, basically, we want to remove, return, not remove, return the results, right? But result pointer is, we are continuously moving it forward. Okay, we have to keep track of the head of the result. So that way we can just simply return next, because dummy, we are not moving the dummy pointer. Okay, the dummy, the node which dummy points to, we are not moving that. But what we are having here is, it's like this. So we have a so this we have a dummy pointer over here. Okay, so this is null, like everything is, the value is not given. Now since it's an integer value, it will be, of course, like initialized to 0, and like this next is pointing to this, so this is the dummy. Okay, and we start the result. Okay, we start the result over here only, result, like it is pointing to this position. So what we do is we keep on moving it like forward. So in this case, the result at the end will like point to something over here. Okay, like towards some null value when the all the both the list ends. So what we have to return is this part, and this part is basically the next of dummy, right? So next node of dummy. So we have to return next, dummy next. All right. There are many ways to do it. This is one way you can do it. All right. Uh, so what we have to do is, if we have to compare list value is less than equal to list to value. Okay. So in this case, if it's equal, unless we will add, so result dot next is equal to, it points to the list one. Okay, node, and then we move the list one to so list one dot next. All right. Else if it's like the value in this thing, list 2 is greater, or less, actually less than, in this case what we do is we just point it to list 2, list 2 node. All right, and then we like move the list 2 pointer to the next available thing. Now once we are done with this, okay, once we are done with this, we have to like move the uh, like the result to the next position, result pointer. Okay, next available location, next. So we move the result pointer, all right, forward. Now while now what can happen is either list one will end or list two will end. So list one, let's say, is not equal to null. Okay, so we keep on adding the result because it's already sorted. Okay, so next will like point to list one, and then list one we can update like equal to list one next. Now similarly we can have list two, in which case list two is not finished yet, like completed yet. So we can simply like append all the nodes from list two. Okay, and we keep moving list one, list two to list two next. And of course, we have to keep moving the result pointer also. Similarly, over here, I forgot to write it. Result next. Okay, the variable names maybe not appropriate over here. All right, but it does the work, and it is. Let's run this. It should work. All right. Yeah, it works. All right, let's submit it. Okay, so this works, and So what is the time complexity and space complexity, right? Let's see. So what happens is the time complexity will be, we have, let's say, m is the length of size of list one, and let's say n is the size of uh, list two. So what we have is we have to go over all the like both the lists, right? Even if one of them finishes first. So basically we are traversing like the whole both the lists. So this will be equal to m plus n, right? And what happens is if you have the space complexity, now space complexity will be also on the similar lines, because we are like concatenating it. Not concatenating, we are just merging two lists. So both the elements from both the list will be present. So basically the space complexity also comes out to be this thing, right? So that's it for today. I hope you understood the solution. Now there's pointer things, you can have a lot of different ways to do it. All right. Now uh, okay, I'll sign off here. Thank you for watching. Have a great day. If you have any comments, you can like post it in the comment section. If you like it, if you have learned something, just like the video. If you want to subscribe the channel. Thank you. Have a great day.